look at the next thing somebody bought. Miss Clark bought 21 for $1. Isn't that crazy? Because if you bought 4 for 50 cents, how can you buy 21 for only twice as much? Okay, so now you have to look at it logically. Since there's no possible way that's anything beside there, this like defies all laws of math. You know that 4 has to be an item, as in the number 4 being on, like if you think on numbers of houses, like you have a house here and you have a number for your house. Okay, this makes sense because she bought 4 for 50 cents. That means that one number is equal to 50 cents. And we look at the next person. Miss Clark bought 21 for $1. 21 has 2 digits, so she'd have to buy 2 digits, which are each 50 cents a piece, which equals $1 whole dollar. It's making sense so far. You just keep looking down. 1,134 looks like a big number, but it's got 4 digits. So 4 times 50, or 0.5, is going to equal $2. So that's your answer. Is the numbers are not quantifying something; they are actual items themselves. That was a little tricky. It took me a while to think about. Okay, and lastly, write on. This is basically just writing an equation using words. Just read it straight across. 8, more than is plus, less than would be minus, a number, x. Whenever you say a number, it's going to have to be a variable. So we're going to use x in this situation. I usually use x. That's the most commonly used variable. And then is equal to 27. When it says is 27, is equal to equal mark. There are other words that mean signs, like of means multiply. So if you say 9 of 7, then it's 9 times 7, 63. So of course you use your algebra rules, and to get x on one side, you're just going to subtract 8 from both sides to get rid of that 8. You're left with x is equal to 19. And so that solves the problem of writing it and solving it at the same time. Okay, let's turn to the back page of this. Hold on just a second. Keeping skills sharp. This is basically just calculations. Let's see. Okay, first one. I really want you to do all of these in your head. It will help you. So if you don't just punch these in a calculator, it would be way better for you. First one, self-explanatory. We've been doing it the whole time. We subtract 8,725 from 10,619. And when I say subtract from is what I see as an inverse subtraction. So if you say 7 from 9, you're not going to do 7 minus 9, you're going to do 9 minus 7. So because you're taking 7 away from 9, so the answer would be 2. Same thing with, let's see, 6 from 1 or something. Getting into the negatives. It's not 6 minus 1, which most people will do. 1 minus 6 is negative 5. So don't get confused with that. You have to really think about it whenever you see that on a test or EOC or whatever. Okay, next problem. 24.96 divided by 80. This, I want you to do long division. It helps me. It helps everyone. So just do it. Okay, so 24.96 divided by, I'll think of this as a house. Think of that as a house. And saying, 24 is saying, bye-bye, 80, bye-bye. He's like outside of the house, right over here. So, in the house, outside the house. Now to do this, we're going to have to ignore this decimal place. Just totally ignore it. But you need to transfer it up there. That's basically what you do. Just ignore that for now. We're going to divide 80 into the smallest number we can. So we can't divide 80 into 2. We can't divide 80 into 4. But we can divide 80 into 249. So, let's see. Whenever you divide into something, the last place of it, the ones place, is where you're going to put your number above the line. So 80 goes into 249 3 times. Make sure you line this up right here, else it could get messy. So 80 times 3 is going to give you negative 160. Well, you just subtract 160. 9 minus 0, 9. 4 minus 6, gotta cross that out, put a 1 there. 14 minus 6 is 6. 1 minus 1 is 0. Now, carry down this number over here. So you get... No, that's not right. That's 8. Yay me. Okay. So now you're going to divide 80 into 896. And that will give you... what will that give you? That will give you a 1. So don't divide into that yet. No, that'll give you a 10. A 10. Okay, this is what happens here. This is really weird to get confused on. I hope I got this right. But if you get a 10 out of something, then you just leave this blank for now, because it's thought of as a 0. A 0 after a decimal has no significance. This is the same as 0.31. Okay. So think of that as a 0, but it's just a placeholder right now. So we're going to subtract whatever 80 times 10 was, and that's 8. 8. Hold on. That's 11. Okay, I got that wrong. That's supposed to be 11. I don't know why there's not another 1 right there, but you're basically carrying that 1, and it's not doing anything for the equation. So you get 880. You subtracted out 6 minus 0, 1, and 6. So you get 16. And you got to think, what I said before, 0.34, you just keep adding zeros. So you know there's infinite zeros after this 6. So you need to add on another one so that you can later divide. You can't divide 80 into 16. So bring down your 0. And of course 80 goes into 160 2 times. And so your answer is 0.312. That one's a little complicated with the decimal, but it's good to know it without using a calculator. Just using a calculator won't give you the logical mindset in math. You definitely need that. Even though you may not use it, it will help you think better. That's the thing. That's the key. Okay, so next one, that one's pretty easy. If you just subtract 15,000 to 34 minus 7,500. Okay, you get 4, 3. Gotta mark out that 5, make that a 4. You're just basically taking a 10 over, so you add a 1. You get 7, and you mark that one out. That becomes 0. There's no place there now. Add a 1, you get 7. So 7,734. Okay, next problem. Next problem, solving for h again, but this time you just add 43 plus 16, which is 59. 81 minus 59 is going to give you 22. But if you really want to solve that and you're... no, I'm not going to do it. That's pretty easy. Okay, write the prime factorization. Prime factorization is basically taking a number, whatever number, and dividing it into numbers until you come to all prime numbers in a tree. You're going to draw a tree that's going to look something like this. It's going to keep going down, and all these numbers down here at the bottom, you can't factor them anymore. So this might be a 2, this might be a 3, this might be a 1, 3 or something like that.